Well, today we're going to understand a topic which is plotting number line for inequalities. Up till now we have plotted the value of x such as 1, 2, minus 5, 4 on a number line. We have even plotted the value of x in a form of fraction like 1 by 2, 3 by 5, 4 by 7, minus 3 by 2 on a number line. Now we'll be plotting inequalities on a number line. How we will do it? Look over here. Like suppose if we have a solution set like x belongs to 1, minus 1, 4 and 5. The value of x is minus 1, 4 and 5. So we simply plot a number line and we'll write minus 1, 4 and 5. We'll just circle these digits to highlight that these are the values of x. Okay. But if we have an inequality like x is greater than 3 and x belongs to an integer, then how will we plot them? So the value of x is greater than 3 and x belongs to integer means x can be anything but 4, 5, 6, 7, 8, 9, 10, 11, but it will not include 3. It will be anywhere like 4, 5, 6, 7, 8, it will go up to infinity. So how will we plot them? We will plot a number line. Okay, we'll simply write minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. We plot number line in a dotted form. Why? That I'll just explain you in a couple of minutes. So the value of solution set for this will be 4, 5, 6, 7, 8. So we'll circle the point 4, 5, 6, 7, 8, 9 and so on. See, but if you notice, I have also circled the point on 3. But all other points are shaded, but the point 3 is not shaded. It is just simple circle. Why? Because 3 is not included. X is greater than 3. That means it is not including 3. The value of x is 4, 5, 6, 7, 8, 9 and so on up to infinity, but it will not include 3. But if the inequation will be of the form x is greater than or equal to 3 and x belongs to integer, then on the same number line we will include 3. At that point the 3 will also be shaded. The 3 will be 3, 4, 5, 6, 7, 8, 9. See, in both the number line are same, but if you notice, here we shaded from 4, 4, 5, 6, 7, 8, 9. There was no need to shade 3, but when it is x is greater than or equal to 3, we have to include 3 because the solution set for this inequation is 3, 4, 5, 6, 7, 8, 9, 10 up to infinity. So, it will be we will also have to include 3 as 3 is included, that's why we have to shade 3 as well. But this is when x belongs to integers or whole numbers or x belongs to natural number. But what if x is greater than or equal to 3 and x belongs to rational number or real numbers? Then we have to include all the values which are between these digits. As you know, there are infinite many rational numbers between any two numbers. Like between 3 and 4 there are infinitely many rational numbers. So we have to include those as well, and that is why if you notice I have make a straight dark line from 3. We have same 3, 4, 5, 6, 7, 8, 9, but the values which are between 3, 4, 4 and 5, 5 and 6, 6 and 7, 7 and 8, 8 and 9 are also included in this equation or in this solution, and that is why we had to make that thing highlight as well. That's why here we had dotted lines. If you notice, we had dotted lines everywhere, but in this from 3 up to infinity we have made that line dark because the values between 3 and 4, 4 and 5, 5 and 6, or I should say between any two digits from 3, the values between are also the solution of the equation. And if we have a solution of equation like x, the value of x is between minus 1, that x is greater than minus 1, but x is less than or equal to 3 and x belongs to real number or rational number, then the solution set again for it will be, we'll plot a number line, we'll plot minus 1 and then we have 3. But x is greater than minus 1, so that's why x is not including minus 1, it is greater than minus 1. That's why we made just a circle, we are not shaded that circle. Then 0, 1, 2 and 3 we have shaded them, and we have also included the line in between because x belongs to real numbers. So it will also include the solutions which are between the digits, which is minus 1 and 0. Like we have minus 1 by 2, we might have minus 1 by 4, or between 0 and 1 we have 1 by 2, 1 by 7, 1 by 8. So all the rational numbers which are between 0, 1, 1 and 2, 2 and 3, including these, 1, 2 and 3 and 0, we have to include them all in our solution. That is why we have made this line as highlighted. Okay, that's the reason we have highlighted these lines. Else, if it would have been integer, if it would have been whole number, then we won't have been highlighting these. We won't have been made a line very prominent. We would have made a dotted line, because that would mean that the rational numbers which are between the digits are not included. One more thing, if we would have over here x belongs to whole number, then the solution -1 to 0 won't have been included in the solution. Why? Because whole numbers only start from 0. Or if it then x would have been belongs to natural number, then the solution would have start from 1, and the solution before 1 would not have been included. So these are the small little things which we need to take care while solving these equations. Inequation, I would say. So let us start with the question, and now first we'll discuss the examples, then we'll move to the exercise. So let us start from example number 1. Like, we have a topic, a simple inequation is given that x plus 2 is greater than 9 and x belongs to whole number. See, here two things are given to us. First is an inequation and second is x belongs to whole number. These two collectively will give us the solution. So, x is greater than 9 minus 2, x is greater than 7. So we just need to solve it the same way like we solve a linear inequation, but just keep in mind when to change the sign of inequality. Now, the solution x belongs to whole number means the value of x will be anything from x greater than 7, so it will be from 8, 9, 10, 11, 12. It would not include the rational number in between the digits. So the solution for this will be, if I just plot it, as such it is a whole number, so we don't need to show negative numbers. We will show it from a positive number, 0, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know I have made a line, a very prominent line. So when we need to make that line darker, we can make it with a pencil or with any other shade. So x is greater than 7, that means the solution set for it will be 8, 9, 10 and up to infinity. So we can just plot 8, 9, 10 and we'll shade like this. So that is the solution set for the x. Okay, let us take one more example, example number 2. Like, we have a question, or let me just clear the board so that, or let me just do it below itself. If solve the inequality 4 1 by 2 minus p plus 7 is greater than or equal to 57, and we need to plot the solution set. This will also be given that p belongs to real number. P belongs to real number. So okay, let us just solve this first. So we have 4 1 by 2 minus p is greater than or equal to 57 minus 7. Just the way we solve normal equality questions. 4 1 by 2 minus p, this will be greater than or equal to 50. 1 by 2 minus p is greater than or equal to 50 by 4. So I get 1 by 2, or I can write 1 by 2 as 0.5 minus p is greater than or equal to 12.5. Now if I bring 12.5, or I can write minus p is greater than or equal to 12.5 minus 0.5, or minus 12p is greater than or equal to, we'll get 12. Okay, so minus p is greater than or equal to 12. Now if I remove this minus sign, if I write p and if I write minus 12, because minus sign when it goes there, the sign of inequality will change. That is a very important point over here. So if we take minus sign to that side, then the sign of inequality will get changed. That is, p is less than or equal to minus 12. P is less than or equal to minus 12. So now we need to find the solution of the equation. So if I plot it over here, and it has also been given that P belongs to R, real number R. So if I take, suppose minus 11, minus 12, minus 13, minus 14, minus 15. Now it has been given that P is less than or equal to minus 12. So that means the solution for this will be, that is P will be equal to minus 12, minus 13, minus 14, minus 15 and so on, right? So we need to include, but this is not the exact solution, sorry, because it will include all the digits which are also included between minus 12, minus 13, minus 13, minus 14, minus 14, minus 15. So what we'll do is, we will first highlight all the digits, and we also have to highlight the line in between. We also have to highlight the line in between, because these are our solution sets. Because P belongs to R, that means it will also include all the rational numbers which are between the digits, and there are infinitely many rational numbers between the digits, and that is why we from minus 12 till minus 12, minus 13, minus 14, minus 15, but along with that we also have to highlight these lines to indicate that these are the solution of the equation. Okay, let us start one more question. Example number 3. See, example number 3 is of utmost importance, because such questions will come in exam. Such type of question will come in exam. So these are the questions which you need to practice thoroughly. Example number 3. Sorry. Solve the following inequation. 2x minus 3 upon 4 plus 8 is greater than or equal to 2 plus 4x by 3 and x belongs to R. So this is the question which has been given to us. Okay, so what we'll do, first we'll solve it just the way like we solve a normal equation. So just the way we'll solve this normal inequation first. So what we'll do is 2x minus 3 upon 4 plus 8 minus 2 is less than equal to 4x by 3. I moved the 2 to that side, so it became minus 2. So next this will become 2x minus 3 upon 4 plus 6 is greater than equal to 4x by 3. Okay, we can do one more thing. We will substitute, we'll transport this 4x by 3 to that side. So this will become 2x minus 3 upon 4 minus 4x by 3 plus 6 is greater than equal to 0. Again, let us take LCM. So this will be 2x minus 3 minus 16x upon 12 plus 6 is greater than equal to 0. In next step, I'll move this plus 6 to that side, it will become minus 6. So this will become 6x minus 9 minus 16x upon 12 is greater than equal to minus 6. So this will be minus 10x minus 9 is greater than equal to minus 6 into 12. This 12 I move to this side for multiplication. Then we get minus 10x is greater than or equal to minus 72 plus 9 minus 10x is greater than or equal to, this will be equal to minus 63, and x, as we cut the minus sign on both the side, then the sign of inequality will get changed. Then this will become 10x will be less than equal to 63, or x is less than equal to 6.3. X is less than or equal to 6.3. So if we plot these things on a number line, so what we'll get it, x is less than or equal to 6.3. So we'll take 6.3 over here. Okay, we'll take 6.3 over here, or we can take 6 over here. We can take 5. We take 4, 3, 2, 1, 0, minus 1, and we have suppose 6.3 over here. So as it includes 6.3, so we will include 6.3 and we'll make entire this line as highlighted. Well, I don't have a marker right now, a different color marker, but you can highlight with a pencil, you can highlight with a black pen or any other color pen, and so that it will be easily highlighted. So the solution set for this will be x is less than or equal to 6.3. So all the values, all the real numbers which are either equal to 6.3 or less than equal to 6.3, all will be included in this thing. So it will include all the digits, we will also include this thing. These are all our solution sets. Okay, and also one more, and we will also highlight the digits in between so that they are also the solution set for the inequations. Okay, thank you.